Welcome to Climate Quickies, bite-sized nuggets of climate goodness from our TEDxLondon experts in under 5 minutes.
In this week's Climate Curious, we're looking up to the skies with food security specialist Catherine Nakalembe. Catherine uses satellite technology and machine learning to monitor smallholder farming and improve disaster preparedness. As the director of NASA Harvest Africa program, she supports millions of farmers while strengthening food security on the continent. Let's head over to Catherine now for a bird's eye perspective on climate. Stay curious.
So I'm very excited for this conversation because I think I'm going to get to talk about like two of my favorite things, food and space. Also, because we're going to speak to another TED Fellow, and as you all know already, because I've been talking about it loads, I love the TED Fellows so much, because you're an awesome group of people. Okay, so let me tell you about this guest, because she's pretty amazing. She's an assistant professor at the University of Maryland in the Department of Geography Sciences. You're the African Program Director at NASA Harvest, which I have like 1,000 questions. And you're also the founder of Xylem Institute, which you're going to tell us more about. Catherine Nakalembe, thank you so much for joining us and taking the time out of a very busy schedule this week.
Well, thanks for having me.
Tell me, what is Xylem and what is space and food got to do with each other?
So if you think about space, what do you think about? Maybe
two things. I think about Star Trek, just going to say it. And I also just think about like this kind of incredible expanse of amazingness and like wonder for me.
So when I think about space, more often I think about all the things that are basically orbiting our Earth, like our planet, and similar to other planets, lots of man-made things that are going around and around, and we call these satellites. And the satellites are, some of them are in space to look out into space, Star Trek, but a lot of them are actually in space to look back down to Earth.
Right.
Our planet A, probably the only option that we'll ever have, and they're in space for many different reasons: communications, navigation, GPS satellites. But we have satellites that take pictures of our Earth every day, and so it's from those pictures, satellite images, that we get to study our Earth. So we can look at water and forests and crops and anything that you can think of that's on the surface and beneath the surface. We can use those pictures to understand what's going on.
That's pretty incredible. But I have a question. How do we use satellite to understand what's going on beneath the surface?
So they are certain satellites, and there's one that's actually going to be launched. They keep postponing the launch date called NISA. And NISA actually is a radar instrument. It has what's called L-band radar that can see below 10 centimeters beneath the soil, and it's used for measuring water, so soil moisture. Wow. And the reason why it's super important is what we see on the surface is just the product of what was in the soil. So if there's water in the soil, the plant will be healthy. And so being able to look at soil or what water is available in the soil, how long it is, and there can actually tell us whether a crop might fail sooner than we would assume.
That's pretty incredible. And I think this brings us on to your work, right? So will you tell us a little bit about what you do?
So I use satellite data and develop methods, AI, machine learning methods to extract information from those satellite data. So I mentioned we have thousands of satellites in space. They take pictures differently. Also, we can combine their satellites for rainfall, temperature, etc. And what I do is combine multiple data sets to, one, map what crops are growing where. So initially it's like, this is crop, this is forest, this is water. So we call that land cover mapping. And then from that, you can go deeper. So you can be like savanna, forest, you can have deep forest, or in the case for crops, you could do cropland, and then you can look at maize, wheat, soy, and then from that you can understand whether maize is doing well because we can combine it with rainfall and temperature. We have images that have been collected in some places since the 70s. You can compare today with 1972, or you can compare 2019 was a drought year, for example, in Kenya, and you can compare today's condition with 2019 condition, which would tell you how bad things are.
And are you seeing trends? How are things changing?
So The data are obvious in some instances. If you think about like long-term climate and its changes in the sense that, one, we have measurements of temperatures increasing. But what is, I think sometimes people misunderstand is the distribution in space and in time. So sometimes we refer to that as variability. So we might get the same amount of rainfall in the growing season, but it might all be concentrated at one point. That is not useful. But also we might get super extremes, so very, very dry periods. And then the other thing is in a lot of places where I look, so I focus on smallholder agriculture for my research within Africa, you find extremes following each other. So you can have 2 weeks of zero rain, followed by extreme rainfall, followed by a cyclone, then an outbreak of, let's say, locusts. And these things can happen sequentially. All of these things can wipe out an entire family's livelihood.
Wow.
And so they're happening really rapidly, sometimes overlapping. Sometimes in close proximity. And then the other side of it is some things might seem so far away from you that they don't affect you. Well, who cares if there's floods in place X and Y. Right. But if you think about an interconnected system, I'm quite sure a lot of people love chocolate. The chocolate comes from cacao that grows in some places, where if it's an entire farmer's cacao field is wiped, or if there's a disease that is making it impossible to produce cacao, you will feel it because the price of cacao, chocolate, will become incredibly high. Right. You can also think that, well, it doesn't really matter if it's getting hotter, but fires 6,000 kilometers away from you could lead to pollutants arriving in your city.
Oh, wow.
So
yes,
there are
of course.
these things that are interconnected that really, really can have extensive consequences for the entire world.
It's so interesting. Okay, so I have to ask you, because I really want to understand, what is NASA Harvest?
So NASA Harvest is NASA's Global Food Supply and Agriculture Consortium. It's basically NASA's agriculture program. And the motivations are that we have lots of satellites, we have lots of intelligence, but bridging between research, there's a NASA Land Use Land Cover Change program, there's a NASA Ecological Conservation program, and the idea is we have data sets, methods, and how do you bridge that with decision making, the examples that I gave. And so it's supposed to be user driven, that we develop methods, data sets, and applications that can directly be applied. And so it's part of, it's under NASA's Applied Sciences program. And it started in 2017, and we've been working in a lot of countries and within Africa prior to actually NASA Harvest. Some of the work that I've done and I've led is basically developing what we call crop monitor systems. And these are now operational in Kenya, Uganda, Tanzania, Ethiopia, Rwanda. And these are sort of systems that a ministry manages, uses for their own internal reporting. So we don't do anything with them, but it's like almost like facilitating a process of making information that would otherwise be very complex into accessible ways, and then it's used for reporting.
Have you seen impact? Like, have you seen them being used and the impacts they're having already?
That's a lot of impact stories. I think one of my favorites is like that moment, and I realized, oh, this could actually really work in practice. And I was doing field work, and that year there was a drought, extreme drought. And I started, for my work, I used to go with more equipment. So that year we're flying drones. I took lots of photos. I recorded videos. And at the end, I wrote this report, and I told myself, I think it's important that I take this to the government. Like, I can't leave with this knowledge. So I did. I gave I shared my information with the Office of the Prime Minister. And when I did, they were like, oh, could you please come and present this on Thursday? There's a committee of ministers that decide on like food security. And this was Thursday. And then on Saturday, they sent the first trucks with food aid, because the evidence was so overwhelming. And so the evidence was, here is a map of where the drought is. Everywhere you see is brown, looks like this photograph. And so it was a combination of photographic information where everybody understands what's in the photo, and then the map that shows the extent of an event. So that transformed into me being involved in the disaster risk financing program, which was how early can we tell that things are going to be bad so we can have alternatives. I've worked for a long time with the Kenyan Ministry of Agriculture, the initiation of their crop insurance program. And one of the things that they're really, really keen on is understanding crop production. So determining if a farmer did their very best, but they fell beneath the average, and trying to compensate them. Okay. Because the world that we live in, the weather doesn't care if you do the right thing, for example. And so with this, in order to determine this way of fairly compensating farmers who are losing because of climate, they're able to, the ministry is able to determine how much and who needs to be paid and when do they need to be paid. You can map anything, you can do it really well, but it means absolutely nothing if it is the best map of how a flood affected a region, without it leading to somebody who can use it to bring blankets, for example, or alternative shelter or food. And so that's kind of like the thing that is central to my work. It's like, I don't want to be, but I want to be really good at mapping crops so I can figure out how we can increase productivity without compromising other ecosystems, wetlands, forests, etc.
I love this joined up thinking, because I do think that we can get, I love technology, right? And all this kind of stuff. And we get so excited by the potential of what it does, but it's just such a good reminder that you need to like join that up with actual things that will help people on the ground make their lives better, easier, survivable. So I think that's amazing.
And there's a big benefit to that. Is like when people's lives are better and easier, they will not do the things or the only option they have to be able to feed their family, which could be cutting the next tree, selling charcoal. So if a person has a fulfilled life and understands the value of their forests, and they value it, they want to protect it. And so being able to make that linkage rather than blame people who are on the front lines.
Agreed.
My favorite line nowadays is when you go where supposedly the people technology could help uplift, 401, early one, make their lives better. It's like when you arrive in these instances, it's like all the technology, all the fancy tools disappear into a black hole because there's no proof that they exist, because people still go about life, they still make the same choices, and they're fending for their lives. But we're talking, sometimes you hear we've influenced or impacted X million farmers. But when you go and try to find these farmers, it's like there's no evidence of this. So it's really important to be truthful about the shortcomings so we can actually address them.
I love that.
Yeah.
I love that so much. Thank you so much for joining us.
Thanks. I absolutely enjoyed this. Thank you.
Thanks for listening to this quickie.
This episode was created by our superstar podcast team at TEDxLondon. Until next time,
Stay curious.